Okay, so welcome to our webinar, everyone. So today we have Ari Berentsen and also Steve Volker from the USDA. So they published a video method with us in 2019. Let's see. So today they're going to be talking about recent updates to the protocol. So they published with us on rabies vaccination markers in mongoose. So today, Steve and Ari will be giving us updates on things that have, improvements that have been made to the method over the last several years. So after the webinar, there'll be a Q&A, and we'll also be sending out an email afterwards with a recording of the webinar, so you'll have that for your records. And, if anyone has any other questions after the fact, please feel free to reach out to us and we can help you with anything. All right. So, Steve and Ari.
Morning, good afternoon, and good evening. Just get my here. There. How's that?
Looks good.
Fantastic. Thank you very much. Thank you for your patience. My name is Ari Berentsen. I'm a biologist with the USDA's National Wildlife Research Center here in Fort Collins. And as I mentioned a few years ago, we published a paper on determining iophenoxic acids in mongoose serum using liquid chromatography and mass spectrometry. Today, we're going to provide a brief method update. I'll be providing a summary of the previous research, and then I'll turn it over to my co-presenter, Mr. Steve Volker. So iophenoxic acids are a white crystalline powder, and they have multiple congeners, and they're typically identified by their functional groups. So either methyl, ethyl, propyl, butyl, isobutyl, and pentyl IPA. Now, this marker has been used for decades, largely to verify bait consumption in a variety of species. And the challenge has been that in the past, in order to quantify bait consumption or measure bait consumption, blood iodine levels were used to determine whether that consumption had taken place or not. And this required measuring those levels pre and post consumption and multiple captures of the same animal. In recent years, we've been fortunate that liquid chromatography and mass spectrometry techniques have been developed to allow us to detect IPA directly in serum. And one of the advantages of this method is that you can actually detect multiple congeners of IPA within a single serum sample, which turned out to be quite beneficial for us in our early studies. To recap, what we did previously is we began investigating this in laboratory trials with some captive mongooses. We offered placebo baits, placebo oral rabies vaccine baits, in two groups of mongooses, either with ethyl or methyl iophenoxic acid at a variety of different concentrations, and the details of that are outlined in the 2019 paper. We collected a serum sample every week from these animals for up to 8 weeks. And then using the extraction methods that Mr. Volker will go through, we were able to actually identify, not only identify the limit of detection, but also a limit of quantification for both ethyl and methyl iophenoxic acid. For ethyl iophenoxic acid, we detected up to 56 days, and methyl, we detected it up to 28 days. And IPA showed a strong marking ability and a long duration of residues in serum. So we were encouraged by these results and decided to expand this research beyond the laboratory and take it into the field. In the autumn of 2016 and the spring of 2017, we conducted trials in southwestern Puerto Rico where we delivered placebo oral rabies vaccine baits with iophenoxic acid across a large area at an application rate of 200 baits per square kilometer. In the autumn 2016 trial, we used ethyl IPA, and in the spring of 2017, we used methyl IPA. For the results of the autumn 2016 trial, using ethyl IPA, we were able to determine that over 60% of the animals we sampled were positive for ethyl IPA, suggesting that they had actually consumed our placebo baits. In the spring, 68% of the animals sampled were positive for methyl IPA. Now, the unintended benefit of the longevity of the ethyl IPA in mongoose sera allowed us to determine in the spring of 2017 that there were some animals that we captured that still had ethyl IPA in their serum. And these are animals we had not captured and sampled during the autumn trial. So we were able to actually pool the samples from both trials and come up with an application, a consumption rate of about 74% of animals that we captured across both seasons were positive for either one or both of the Iophenoxic acid congeners. And this was also very useful because it allowed us to determine whether which season the animal had consumed the baits in. Some animal consumed only in the autumn, some only in the spring, and some had also actually consumed baits during both field applications. So what we learned from these early laboratory and field trials was that iophenoxic acid, we were able to use liquid chromatography and mass spectrometry to detect and accurately quantify the residues in mongoose serum, both in field trials and in laboratory trials and in field application. We determined that this was useful as a biological marker to estimate placebo oral rabies vaccine bait consumption in mongooses. But as with many things, the more we looked into it, we realized that there would be room for improvement in some of these methods to try to streamline the process. And to explain that process and the changes that were made to the extraction methods, I'd like to now turn it over to my co-author, colleague, and co-presenter, Mr. Steve Volker, who is one of our resident chemists here at the National Wildlife Research Center, and who's been responsible for a lot of this method development. Switch. Oops.
Well, thank you, Ari. Good morning, everyone. So I will be covering modifications that we've made to the method over the last 4 years. So in overview, the method presented in JoVE in 2019 has been used extensively at NWRC over the last 4 years. The method evolved incrementally as needed, with more than 5,000 samples being tested to date, and in 8 species. Additional IPA congeners have been evaluated in several several lab trials, adding to the utility of the method. Due to the large number of samples being tested, recent efforts have focused on trying to streamline the process. So I will be talking about 2 new procedures in greater detail. So this is the methodology that is presented in the JoVE paper. I'd like to just go through and describe, kind of walk you through the workflow. So we start out with 50 microliters of serum, and then we add our internal standard. In the original method, that was the propyl iophenoxic acid. And then we add 950 microliters of acetonitrile that contains 0.5% of trifluoroacetic acid. And this is all performed in a 1.5 milliliter microcentrifuge tube. And at that point, we have everything in the tube, vortex mix it. And then we have the addition of sodium chloride. So that causes the ACN to essentially be salted out. So it forms 2 liquid layers. So this mixture is vortex mixed, centrifuged, and then we transfer a portion of the supernatant into a separate tube. Then we remove the solvents, reconstitute it in mobile phase, transfer that into an HPLC vial, and then it is ready for analysis. This is the summary chromatogram illustrating the chromatography that we're achieving. And so originally, several slides back, I already had an image showing the methyl, ethyl, and propyl. So as you can see, we have the addition of the isobutyl, N-butyl, and pentyl IPA, and that's all being eluted in less than 8.5 minutes. So now I'll talk about a revised workflow that we've performed experiments on it, but it is not an officially validated method. I've highlighted in red the portions that are new or have been changed. So I'll describe this. So we're adding the 50 microliters of serum, but then an important step is the addition of 100 microliters of water. And what that does is it just dilutes the proteins so that when the acetonitrile is added, it prevents the clumping of the proteins, which was observed in the original method. And I'm adding a smaller volume, so 450 microliters of the acetonitrile. And we had to change the acid from trifluoroacetic to formic. And that is because trifluoroacetic acid under the MS conditions that we're running would really severely suppress the signal. And the recovery of analytes using this procedure is nearly identical. So simply acidifying, regardless of the type of acid, was critical. We vortex mixed that, and in the original method, we were sonicating. This is a step that I'd like to evaluate further because it adds a considerable amount of time. If that can be omitted, then great. But at this point, I don't have the data set to support that. And then we add sodium chloride. That causes the two layers to separate. And vortex mix that, centrifuge it, and then this is where it's different. We simply skipped a step here. I'm transferring it directly into the autosampler vial. And then to that, we add 300 microliters of the 0.1% formic acid. And then it is ready to go. So by eliminating the dry down step, that saves a lot of time. And well, nitrogen is not free, so we are saving money in this as well. And now I'll talk about a very different kind of technique. This is a proposed technique that has just been tried out, but it hasn't been fully vetted yet. And this uses technology that's come around in the last few years of the phospholipid removal. It looks like an SBE cartridge. So in this process, we add the formic acid, 250 microliters, and then add the serum. So it's sufficiently dilute, and then add the internal standard, followed by 150 microliters of acetonitrile that contains the 0.1% of formic acid. So at this point, the whole liquid layer is sitting on top of the SBE bed, and the proteins have been precipitated out. And then it's important to vortex mix that, which can be kind of tricky. Vortex mixing an open tube, but it doesn't require much. And then using a vacuum manifold, we elute that directly into the autosampler vial. So as you can see, this would be a very simple method to perform. One obvious concern is that these cartridges, cost a fair amount. So when you're running thousands of samples, that's an important variable. And so in conclusion, the original method has been used for quite a few species beyond mongoose, including raccoon, fisher, skunk, bobcat, gray fox, coyote, and recently opossum. Revised extraction procedure has been demonstrated to save time and cost with no loss in the method performance. The phospholipid removal cartridges may provide an even greater savings in time, but needs to be evaluated further. And Ari and myself and this frisky looking mongoose would like to thank you. And happy to take your questions. So I have a question here. Do you see differences in detection in species? We certainly do. I would say that actually the recent work with the opossum, and I believe that is the only marsupial in North America. And the clearance of the any of the IPAs is very rapid from the opossum, as compared to one of the earlier slides that Ari had shown in the mongoose, where it's almost as if you reach a steady state level. It's not, it does decay over time. So yes, there is a dramatic difference. And I have a question here. Okay. Do you believe this biomarker could be used in dogs and cats in the future? I would think it would work quite well. Maybe, I'm not sure if this would be a concern, but I know that iophenoxic acids were in the past used in humans, and in that case, they were used as a contrasting agent for, I would imagine, MRI. And that has been discontinued for the reason that it stays in the body for so long. Here's Ari.
I'll jump in to add to that. There is some early research on publication on cats and brush-tailed possums. I think that's the Easton Bachelor paper from back in the late 90s. And there has been research done on IPA retention times in dogs. And they found that in dogs, I believe the retention times were up to a year. So again, that interspecific variability of retention times does play a role, but it has been evaluated in cats and in dogs in previous work. So that's a very good question. The question is, what would the optimum concentration of IPA be in a bait? That will be, I think, also species specific in some regards, based on some of the retention times. In our mongoose study, we went with 2.8 milligrams in our field trial, and we had excellent marking ability. We are considering a new study coming up where we reduce that to 1 milligram in each bait. Based on our previous work in the laboratory, we saw very good marking with the methyl IPA at 0.07 milligrams. And given the sensitivity of the analysis and the method limit of detection and method limit of quantification for these for mongoose, we would expect 1 milligram to be sufficient. But there is some more research that needs to be done depending on the species to optimize those concentrations for adequate marking. And it also depends on the duration of marking that one is seeking. If they're looking for something to be there for a long time, to be able to detect it 6 to 8 months out, doses may need to be increased for that. A question from Conrad. Hi, Conrad. It says, thanks. Can you also comment on costs per IPA and cost per investigation? I don't have an exact cost on the IPA. The challenge that we have with iophenoxic acid right now is ethyl iophenoxic acid is commercially available. The other derivatives, the congeners, the methyl, propyl, butyl, pentyl, and isobutyl, the manufacturer who is making those is no longer in business, so they would need to be specifically synthesized, which can be a very costly process. But the ethyl marker is still commercially available. And perhaps you can speak to the analysis.
Yeah, only having just the ethyl to work with, it does kind of complicate this methodology bit, because you do need one of the other congeners to serve as the internal standard. So at this point, work is underway to see if we can have these manufactured, and if they're manufactured for us, then I would think they would be available elsewhere. All right, I don't see any additional question. Oh, here we are. So what about the half-life of IPA? Is it species dependent? It would, from what we've seen in marsupials versus other rodents and or mesocarnivores, I believe would be a more accurate term of several of those animals. Then yes, absolutely, the half-life varies very much based on the species.
Okay, so I believe that's it for questions. I don't see any others. So I just want to thank you both for an excellent presentation here today. And we will send an email with a recording of the webinar after this, so you'll have that for your records. And if anyone thinks of any other questions, feel free to respond to our email, and we can help you out with those. All right, so yeah, thank you everyone for attending today. Greatly appreciated. And
Thank you very much for the opportunity.
Yes, thank you very much.
Take care, everyone.
Yeah.